Okay, so this is going to be a quick tutorial on how to find the greatest common denominator, factor, divisor of two numbers in Python. Okay, so first of all, I want to say that this is kind of a, I guess, naive method because uh, Python has built-in libraries that kind of take care of this, but I'm going to explain algorithms, iterative and recursive algorithms that will carry over to other coding languages and will also work for Python. But I'll get this out of the way first, but probably the easiest way would be to import a math library. And then I'm just going to say parameter of, let's take two numbers, 5 and 25 is, and then we can use our math library, and it has a greatest common denominator function of 25. So this is what it would look like. And it should just output GCD of 5 and 25 is 5. And there it is. So that would probably be the easiest way, but that would make for a pretty short video. So I'm going to go over, explain the iterative and recursive ways to solve this. I'm just going to get a little whiteboard going here. All right, that's good. So the greatest common denominator is the largest number that can divide two numbers. For example, let's say we have two inputs, 4 and 6. So they're all divisible. Well, 4 is divisible by 2 and 1. And 6 is divisible by 3, 2, and 1. So here it's easy to visualize that 2 is the largest number that can divide both of them. So that's just kind of explaining what a GCD is. But let's go over algorithms that can solve this for us. So let's keep the same example and switch them up. But iterative algorithms, I like to think first of loops and counters, and first the value that we're going to count to. So you might have noticed that the GCD can never exceed the smallest number. It always has to be a value in between, for our cases of positive integers, between 1 and our smallest value. So that is going to be our counter. So we can say while, let's use I is less than 5, we'll go from 0 to 4 for this example. And then we want to test, we're going to use the modulus function here. And the modulus, we'll do an example, is the remainder. So yeah, the modulus function just finds the remainder. So we want a remainder of 0, which means it'll divide it perfectly. So if our values of x, the remainder of that, and I is 0, and the remainder of our second number and that I are 0. So that both have no remainder for that number. Then we found it, and we can return our greatest common denominator. If not, no, we don't want to go from 0 to 5. Apologies, because that would be the least common, or no, not the least common, the smallest. We want to find the greatest, so we want to count down. So well, I is greater than 0, and we can count down from 5 in this case. So we'll just I minus equals 1, and we'll just go through there and do that. So that's the iterative way to solve that. Now onto the recursive method. I find that recursive algorithms are a decent bit harder to visualize, but I like to think of them as continual guessing and checking, so over and over again. And in this case, we are checking for denominators, and we're going to use the modulus function again. So we want to check division over and over and over again. And so I'm thinking that if we test a number and it doesn't divide evenly, we can test the remainder of that. Maybe that's the divisor. And if that doesn't work, we can do the remainder of that, and we'll slowly work our way down, dividing our largest number by our smaller number and smaller all the way to 0, but they'll be more educated per se guesses than our counter algorithm. So the way that's going to work is that we're going to, and this is kind of how recursion works. You start at the end of it, but we're going to take one of our values that's going to hold on to our remainder. So let's just set it as y in this case. This is going to be our condition, but y, and then our remainder. So we keep taking remainders until we find one that is 0. So if our condition is met, then we can break or return the other one and break, else we want to keep calling ourselves. So the way I'm going to step through this mainly just to show you how it works with this example. So let's take, okay, let's start off. So our y is 4 right here. That is not equal to 0. So now we're going to call ourselves again, this time with our y 4 and our x modulus y 6 mod 4. So that's going to be 1 remainder 2. And again, our y here, so is not equal to 0. Call ourselves again with the previous remainder, because we want to hold on to that, keep getting smaller and smaller remainders, and our x modulus y, which in this case is going to be 0. 4 divided by 2, 0. I mean 2, remainder 0. And now our y is 0, so we can return our previous remainder and largest common divisor 2. All right, so that's how the algorithms work, and now I'm going to jump into coding them. I pretty much outlined them entirely, so if I'm coding and you get confused about how they work, I'd come back to this section. But now I'm just going to hop into Replit, where I have a main file and then both of our algorithms for clarity. The way it works in Replit with different files is you need to import the arguments within the other files. So if now that we have them in there, we can set up our user entered variables. So we can say, we'll just call them num1 through 4 of type integer. We're going to take advantage of the input function in Python, which will take keyboard input from the console and assign it to our number. There's number. Okay. And we can use this 4 times, but not with number 1. Okay, so now we have that all set up. We want to enter our functions and print the results of them. So print the GCD is, and then since this will be in another file, we have to do that iterative dot. Let's call our algorithm GCD iterative, and it will take parameters number 1, number 2, and then we'll have them run at the same time. So let's do the other one. C is, and then let's call our recursive algorithm GCD recursive. And it's going to take parameters number 3 and number 4. So that we have that all set up with correct spelling. Okay, we have that all set up. Okay, now we can go into our algorithms. So for here, this is how Python works. This is how functions are defined in Python. Iterative, and it's going to take, let's assign it to A and B, and okay, and now we wanted to find our counter, so that's going to be the smaller number. So to code that, we'll just say if A is less than B, then our small number is A. If it's not A, that has to mean our small number is B. So now that we have that set up, we can go into our loop while our counter is less than 0. If the remainder, and oh yeah, that's the and in Python. I wrote it like this. Another one that's C, but this is, you can just write and in Python. B mod small. So if remainders are both 0 for those, we have found our target. And we can return small. So outside of that, we want to decrement our counter. It can be done like that with the minus equals, or you can say small equals small minus 1, but it's a little bit longer. And then if that all fails, we'll just return a fail, 0. So that's the iterative method. Now we can move on to the recursive, which should go a little bit faster. So we need to define it, and it can take, we used A and B for the last one, so let's change it to X and Y. And we had our Y, our previous or remainder. If that's 0, then we can't just write Y equals 0. There we go. Then we can return our GCD. If not, we have to call ourselves again with our previous remainder and our new remainder that we are going to test. Okay. Our function's not called GDC, it's called GDC rec. Okay. I'm wondering why. There we go. Okay. It's chilled out. So let's run it, and hopefully I didn't spell anything wrong. It's taking a bit. I'm not sure why that is, but okay. Well, I forgot that. So yeah, remember, let's go at the end of these conditionals. And again, yes, colons go at the end of the conditionals. Okay. All right. Now that we got the syntax out of the way, we can test our example case of 4 and 6. And then we can also do, let's do 64, 64, 8. Okay. So I messed something up on the iterative version, small, because that sign, small is greater than 0. We're counting down. My apologies. Okay, now that should be good. Yes. GCD of 4 and 6 is 2. 6, 4, and 8 is 8. So that's all good. And that is, or those are the two algorithms, and they will carry over to other languages.